Hello viewers, in this tutorial we are going to learn about Oracle Real Application Testing or RAT, which is a very useful feature in Oracle to compare performance of the database during any major change in the database environment, such as upgrading the version, migrating the platform, or upgrading the hardware, etc. And I will walk you through all the steps required with practical examples to perform a RAT step by step. So what is RAT? Oracle Real Application Testing or RAT is a feature that enables you to perform real-world testing of Oracle database performance. RAT is based on workload capture, workload replay, and SQL performance analysis, by which we compare the performance of a database before and after a change. This change can be a database upgrade, say you are upgrading your database from 18C to 19C or even a newer version like 21C, or you are migrating your platform, say from Windows to Linux, or you are upgrading your hardware from, say, a traditional server to an Exadata server. For this kind of major changes, RAT will let us know how the database performance will be in the new environment. RAT helps us evaluate a candidate database's performance even before we actually go live with our changes. So how RAT works is, first you need to find out a time period in your source database when there is a representative workload from user or application activities. You capture that workload as some SQL tuning sets or STS in the source system, transfer the workload to the target system by, say, export-import, and then replay the workload in the target system using some inbuilt methods, procedures, functions provided by Oracle. Once your replay is completed, you extract a few AWR comparison reports from the target system, which gives you a full analysis of how the performance of the database during the representative workload replay. With the analysis and comparison reports, you can find out many performance related metrics like load in the system, wait events, resource consumption, execution time and plan of SQL statements in the target system, and get a fairly nice idea about how your database will behave after the actual cutover or go live. And if you see any performance issues, you can fix them by tuning further, like changing the memory footprint, adjusting any initialization parameters, or creating SQL profiles, etc., etc., and do the workload replay again to see if the situation has improved. I have used this feature more than 100 times when I and my team migrated 500 plus databases in AIX to Oracle Exadata in a massive project that we handled a couple of years back. Even now we use this feature when we do a major database version upgrade. With RAT, we can produce reports that provides evidences with a before and after comparison of an upgraded or migrated database and identify the real cause of an issue, if any. For a RAT testing, you need a source database and a target database. Target database does not have to be an exact current copy of the source. It can be an ARM and restore database or an export-import copy of the source database. But in terms of application schemas, or the schemas in which you are evaluating the database performance, the two databases should be structurally similar. Otherwise, the workload replay will fail in the target or throw some errors due to missing schema objects like tables, views, types, or other database objects, because workload replay in the target is nothing but executing a set of SQL statements and PL/SQL blocks that was captured from the source database. For this demonstration, I will use an Oracle 18C database named CatDB as my source database and an Oracle 19C database named RAT-Test1 as my target database in an Oracle Enterprise Linux 7.9 environment. I will create a mock workload in the source database by running a PL/SQL block with a few SQL statements in an infinite loop for 15 minutes and capture it by running RAT commands. Then I will transfer the workload and replay it in the target system. Please note that in a real database system, you don't have to create a mock workload because there is always something going on from the application or user activities. You just need to select the right time period, say an 1 hour or 2 hours period during the peak hours to get a representative load. I will divide this entire topic into 3 parts to avoid making the videos too long. In the first part, that is in this tutorial, we will create a mock workload and capture it in the source system. In the second part, we will transfer and replay the workload in the target system. And in the third part, we will extract the comparison reports and make the analysis about the database performance. So let's start. So before we start the RAT commands, let's establish our test case one more time. Say we are planning to upgrade our 18C source database to version 19C in the same Oracle Enterprise Linux 7.9 platform, and we want to see how the database performance will be in the Oracle version 19C with a representative workload. So I logged into my Oracle Linux 7.9 server as Oracle user, and this is my server, rated Enterprise Linux 7.9, and I have 2 databases here. The CatDB, which is our source database in Oracle version 18C, and the RAT test 1, that is our target database, which is in version 19. I established a toad session to the 18C source database for executing certain queries to prepare the environment. Any SQL statement or PL/SQL block that I am using in this tutorial can be found in the shared document in my Google Drive. You can find the link to that document in the description of this video below. So first, I am going to create an application user named app user. In a real environment, you don't have to create this application user because there will be application related schemas and users which will be doing their relevant activities. But this is a test database, there is not much going on there. That's why I need to create this user with a password fuser12345, and I am granting some resource, connect and DBA privilege to the user, and I am also creating 3 sample tables and some indexes on those tables. And these tables are created from the DBA objects, DBA tables and DBA indexes dictionary views. So I'll just execute these commands as a PL/SQL block so that the tables and indexes are created under the app user schema. There will be a few hundred or thousand records in these tables, and that is enough for our demonstration purpose. And I'm creating one PL/SQL block which is consisting of 3 SQL statements which will be executed in 5 seconds interval. And these SQL statements will be executed in an infinite loop, and this entire PL/SQL block will be executed in a SQL plus session. So I'll establish 3 SQL plus sessions using the app user that I just created, and I'll connect to our source database and execute this PL/SQL block. As it is an infinite loop, it will continue to run until and unless we terminate the session. So let's start a SQL plus session, and I'll connect to our source database, that is the CatDB, using app user CatDB, and the password is fuser12345. And I'll establish another session. The second session, and also a third session. And in these 3 sessions, we will execute our PL/SQL block. The first session, the second session, and the third session. Now that our 3 sessions are established, we'll be able to see them under $sessions view. And yes, we can see that there are 3 sessions currently running, and they are executing those SQL statements to create a mock load in our database. Again, if you are in a real database environment, you don't have to set this up. because there will be always something going on from the application, and all you need to do is to capture that activity. Now we will execute the actual read commands to capture the workload. But before we capture the workload, we have to do certain preparation activities that I am going to do step by step. First, I will connect to the source database as sys, and this is our 18C source database. We'll also open one command prompt in another tab so that any OS related commands can be executed in that tab. So I'll sudo to Oracle user, and here I will create one directory to keep all the captured files. And on this physical directory, we will create a directory object in our database. Let's create the directory object as catdb capture, which is pointing to the physical directory that we just created. Now we will grant read-write permission on this directory object to public. Now the next thing, we need to set up some filters, and this filters is actually filtering in the schemas on which we are going to capture the workload. In our case, it will be the application user schema that we just created with a name app user. So we are going to create the filter using this command dbms workload capture dot add filter user filter, and the user is app user. So the filter is successfully created. Now you can check out the filters that we just created. I will simply check the name of the filter that we created. The name of the filter is user filter. There is no ID associated yet, and the value of the filter is app user, that is our application user schema. Now we'll start the capture, and the capture is nothing but whatever SQL statements are getting executed by the 3 sessions that we just established using SQL Plus, and this capture process will capture those activities. And the command to execute the capture is dbms workload capture start capture, and this is the name of the capture that we are putting here, and it can be anything. I am putting here the name of the database, the capture word, and the date on which I am doing the capture. And we need to specify the directory object where the captured files will be created, and this is the catdb capture, and 900 is the number of seconds for which this capture process will execute. And this exclude word here is actually specifying that whatever filter we have established before, except that filter, it will exclude any other user activities or application activities. Once we execute it, it says the PL SQL procedure is successfully completed. It means the capture process has been submitted, and it is now internally running for the next 15 minutes. Please note that in a real environment, running a capture process for like an hour or so, or maximum 2 hours is sufficient. You don't have to run it for like 8-10 hours long capture process during the peak period. Now whether that capture process is currently running or not, you can find it using this SQL statement. What I'm doing here is select ID, name, directory, directory path, status, filters used from DBA workload capture, and this is simply giving us that a capture named catdb capture 032522, that is the today's date, and it is keeping the captured files in the directory named catdb capture, which is pointing to this physical path, and the status is in progress, and this is using one filter that we created before. Please note that if you want to stop this capture before it automatically finishes upon completion of the defined period, you can also use another command called dbms workload capture dot finish capture. If you execute this command, then whatever capture is currently in progress, it will be stopped. And instead, we will wait for 15 minutes to complete the capture. And you can repeat this SQL statement. And it is still in progress. Let's execute the query to see the status one more time. It is still in progress. Okay, we just completed 15 minutes looks like. Let's see the status again. And yes, now the status is shown as completed. The next step is to create a SQL tuning set. So I'm using the DBMS SQL tune create SQL set, and the name of the SQL set is SQL set catdb and today's date. Description: catdb SQL set for replay. And we'll execute this procedure, and the SQL set has been successfully created. Now that capture process has completed, and we'll be executing the next level of commands in our Toad window so that it becomes easier to understand. And the first SQL statement that I'm executing is giving us that the capture process has completed. Next statement we are going to execute, which will give us the AWR begin and AWR end snapshot, which is relevant to the capture process that we ran for 15 minutes. So for that 15 minutes time period, this is the beginning AWR snapshot and this is the end AWR snapshot. These AWR snapshots are important because we have to take all the SQL statements which are in between these two snapshots that will include in the SQL tuning set that we just created. So what we are going to do in this PL SQL block, in the declare section, we are defining one cursor, and in the begin and end block, we are running a cursor for loop and collecting all the SQL statements in between these two snapshots 4670 and 4671 and including them in the SQL tuning set that we created. So let's execute this PL SQL block, and the PL SQL procedure successfully completed. Next, we have to create an user in the source database which will be used to pack the SQL statements in the tuning set, put it into a table, export that table, and import that dump file of the table in the target database. I am simply keeping the name of the user as STS1. Say create user STS1 identified by welcome1. It's just a temporary user we are creating for the purpose. So the user is created. Then I am granting it some privileges. So connect, create session, create table to STS1 user. And I am granting unlimited table space to the user. Now I'm going to create a staging table in this STS user schema. So PL SQL procedure successfully completed. So we just created the staging table. Next, we are going to pack the tuning set that we created. So here we are using the DBMS SQL tune dot pack staging table underscore SQL set, and name of the SQL set is the one that we created before. The SQL set owner is sys. Staging table name is STS capture catdb that we just created, and the staging schema owner is STS1. Let's execute this PL SQL block, and the PL SQL block has been successfully completed. Next, we are going to export this table using expdp in the command prompt. I am just pasting the command here so that it becomes easier to understand, and I'm going to use the sysdba user, and the dump file name will be sts capture catdb.dmp. Log file will be similar .log. The directory will be the one that we created before, and the tables is nothing but the sts1 user dot sts capture catdb. This is the table. So let's copy it from here and I will go to the command prompt and I'll simply run it. And our export activity has been successfully completed. Now we need to export the AWRs, and to do that, first we have to find out the capture ID. So we'll go back to our Toad window and execute the command which gives us the ID, that is the capture ID, name, directory, status, etc. And most importantly, we need this ID field, which is 1 here. And next, we need the AWR reports for that particular capture ID. So we are executing the DBMS workload capture dot export AWR for the capture ID 1. So we'll simply execute it. And this statement is going to take some time because it is actually exporting all the AWR related information for this capture ID for the period that we use to capture the workload. And all this information are actually written in some files in the directory that we created in our file system. So if you go back to the folder that we created, you will be able to see that there are some files created here, and these are the capture files and the SQL tuning set table that we just exported, the log file, and some directories related to the capture files. So we have to wait until this process finishes. It usually takes like around 5 minutes. It is based on how big is your workload capture. Now in fact, our capture process finished long back. We don't have to continue running those PL SQL blocks in the SQL sessions that we established. So we'll simply go and terminate these sessions. The second one and the third one. Okay, after running for around 8 minutes, the export of the AWR procedure has been successfully completed. Now we are in the last step of completing our capture process, and for that we have to go to the OS level and see the size of the directory that was used to keep our tuning set dump file, all the AWR snapshots, and any capture related files. And it's 49 MB, and we need to zip this file and transfer to the target system where we want to replay our workload. Now, whatever workload we just captured in our source system, everything is packed inside this folder. So this folder needs to be transferred to the target system to replay the workload. So we will first compress this as a zip file and name it as catdbcapture.zip. So we created the zip file. So with this, I am concluding today's episode where we completed the workload capture in the source database. And in the next video in this topic, we are going to transfer the workload that we captured and created the zip file to the target system. We will uncompress it and then we'll replay this capture in the target system. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.